Hi, thank you for attending the learning section on crypto price prediction models. So let me give you a brief introduction of myself. So my name is Jeremiah. I'm currently a master's student at Columbia University. My major is operations research, and I'm a data scientist intern at Deephaven this summer. My major task is to develop some interesting projects using Deephaven packages. So let's get into the big pictures of the crypto price prediction model. So in order to train such a model, we need to have a historical database. So I use the API Airflow to automate the data acquisition process. After I got the data, I train the data set on LSTM model and on linear GPU model. And after that, I use the table replayer to simulate the traits as it comes in real time to test out the model performance. Also, I also connected to Coinbase API to do some real-time prediction. After that, I use the URI package to share the prediction tables with the other machines. So for the there's like a website called the Crypto Data Download. Let's navigate to the website. So if you go to the website on the historical data section, there are like a bunch of like exchanges platform grouped by countries. If you're clicking into the Jimmy exchange, for example, you'll see like they have crypto data by day, by hour, and also I think the most frequent one is by minute. So now we have like two choices here. So we can like just use those data, which is by minute, or we can connect to like a API, for example, Coinbase API. I think they have data by minutes, even or even by like by seconds or even by millisecond. So we can wait for like a couple of days to collect the data and use it as our data set. So for here, I choose only use the minute data because I think because they have like the crypto price data by minutes for the whole year. So I think the model can learn more information out of it. Also, if it's the project for demonstration, if we can build such a model, then it doesn't matter. It won't it will like apply to like any time frame. So I use the APAC Alfro to build like a simple data pipeline. Let's say the installation part. I mean, like the installation is like pretty easy. You just follow the steps to install the correct version. And after that, you have to initialize the database and create the username and the information. Then you can start the server on port 8080. So on port 8080, you can say I already create a deck called crypto, and you can see the runs, how many runs I did, and also the schedule interval, and also the time of the last run. Inside the crypto deck, I have I create a Python script, basically that automatically download CSV file and grab the data and the price column and store them into Parquet file. So I was trying to do it inside Deephaven server, but it did not work. So I chose to do it like outside the Deephaven server. So after data is prepared, we can start to build our model. For here, I trained my model on LSTM and also linear G. I trained my data set on LSTM model and also linear GPU model. So let's take a look of the code. So basically, the PyTorch version and the TensorFlow version are pretty similar. So we just look at the TensorFlow version. We say we have the code to connect to the server to use the Deephaven package. We'll also have like a bunch of Deephaven imports and also Python imports. So for here, I wrote a code to only access the latest file, like the newest historical file, and do some only pick like a subset to just show the demonstration purpose. And I also did like a train and the test split, use Deephaven package. And yeah, here I defined like a very simple STM model. So basically, you can extend based on that. And I use like a mean scatter function here to scatter the data. So it's just gonna make the training process like faster and smoother. So basically, the rest just follow the basic learned structure. Okay, so I also use like NVIDIA wrappers to train the linear GPU model. We can take a look at the code. So for the above, just the same bunch of inputs and connection. For here, in order to basically the NVIDIA wrappers works like yeah, enables you to use like you enable you to like develop your data science project fully on GPU. So meaning like you can do data manipulation, also training your model on GPU, but it does not support like on Deephaven table. So I have to like switch back forth between like Deephaven table and pandas to perform like to show how to use it, how it can be used on GPU. And for training time series linear model, you have to create some sort of lags. So for here, I use like past 3 minutes to predict the current minute. You can like do more lags to see if like you can get like better result of it. So to use like a linear GPU model, it's like quite easy. After you install the package, you just import linear regression from CUML. It's gonna give you like give you linear GPU model. So the rest also follows like the basic learned structure. So after I train the model, I use time replayer to simulate the trade. So the time player package is just replayer package is just like very easy and straightforward. Um, After knowing the time range, you can use like np.min or np.max to get the time range of the historical test data. After knowing that, you can start your simulation and do the prediction work. Say on the left, I have the GIF, which has the predicted price, and also against the real price. We say like they are like pretty close. So I also connect to Coinbase API to do some real time prediction. So Jake has like a very detailed blog and explanation on how to connect to the API and connect to Coinbase API and get real time data. He basically listened to like every transaction from Coinbase, but for me, I only need the price per minute. So I basically create a function to calculate the average price by minute. Then use like a dynamic table writer only listen to this data. So last time I showed you, like in the last slide, I showed you how to performance prediction linear GPU model. So now I'm gonna show you how to use our STM model to do real-time prediction. So, but you have to pay attention on the input, the first input data, since there's like some time lags between the time you train your model and the time you use it in real time. And also for your training set and the real time data set, there's like maybe some time lags. So basically, I pretend the last for here I use like last 3 minutes to predict the current minute. So I pretend the price in the last 3 minutes gonna just be the same as the current minute. So by doing so, I was able to get like a more accurate result, and this method won't hurt the model too much, since indeed the crypto price won't change too much just in few minutes, and also as the model goes, the effect just gonna decay. So here are some plots of the LSTM model on real-time crypto data. We see like we see on the right, after I think the plot is like after 3 hours, and we see there's like a gap between the real price and the prediction price, but not too much, just like less than $200, I guess. But we see like the model actually captured the trend. When the price go up, it actually go up, and when the price goes down, it actually goes down. So it's pretty good. So we also can use the URI package to share the prediction table. So if you want to share the table like across the ports on your local machine, you can just like if you have your prediction running on port 10,000, and you can start another port on, for example, 8,000, with this single lines of code, URL the resolve, and the localhost 10,000, and the prediction table name, you are able to listen to the real time and listen and watch to the real time table. So if you want to share with the other machine using the same network, you can simply change the localhost 10,000 to your network IP address. That will work. But if you want to share with like more people, for example, like across network, I haven't tested this out, but I think you can publish the results online, and then I think that will work if you have like another server. I think that will work. So those are some like improvement on the model. So if we can find a data set which has like crypto price by second, I think it's just gonna learn train over model on that. It's just gonna give you like a more like a real world model. So if we can including like volumes and also market sentiment analysis, that will make our model robust and also more accurate. Also, if we can apply like a complex and advanced machine learning model, that would also enhance our model and make it like more accurate. So let's get to the last part. So the learning of the summer. So for this summer, I did not like only learn technical skills such as WS2, Docker, and a lot of like machine learning skills. But I also learned like soft skills such as like communication, how to deliver you like a result, and how to start your project from scratch. Those things like are very helpful, and it would be like a very valuable experience for me. So thank you.
Thanks, Jeremiah. It's been great working with you. Since you've used Deephaven for a few months now, can you give us your thoughts about, what that experience was like, as well as, what other, industries or projects it might be useful in?
Okay, so yeah, I feel like Deephaven is like a very powerful platform. You just make like the machine learning project, like data science project, like more structure, and also it provide like a fast computation for you to do the project. I feel like you can apply the you can use like Deephaven like in so many fields. Like for example, house ability to predict like a cancer rate, and also real estate like to predict real estate value, like housing value, and also yeah, it's like I found that it's like so useful in doing some like a stock or crypto prediction. You just um save you a lot of time, I think.
Great, thanks. Any other questions?
Yeah, I was curious. I saw that you used Rapids. I just out of tangentially, my brother works for NVIDIA, and he's one of the guys who works on the Rapids project. And I talked to him about, how interesting it would be to try to get Rapids to work more natively with Deephaven. What would have helped the most to get that particular piece of this puzzle easier to use?
I mean, like I feel like it's. I mean, for the model part, I mean, like you can train the model easily, like with Deephaven learn package. But just for the you just like have a little bit of trouble between like switch the table like Deephaven table to like CUDF table. I think I just haven't like solved that yet.
So
if we were,
I think the way Jeremiah approached it, I think there are things we can do to avoid those problems. It's just, I think producing some examples would help.
cool, very cool project. Thanks.
Thank you.
Yeah, I have a question too. You spent basically the whole summer doing AI projects, some pretty cool ones. Now that you've used PyTorch and TensorFlow and now NVIDIA Rapids, would you say you have a preference on which AI package you like the best, and I guess why do you like one in particular if you do?
Yeah, I feel like it really depends on the project. I mean, like basically, I feel like using PyTorch is just like you have to write more code than using TensorFlow. I think that I mean, like for TensorFlow, people already like have like a native. I would say like a very simple way to use it, like very examples. But for PyTorch, like I mean, you have to write all the training parts and all the stuff by yourself. So I would like I'm like prefer I prefer to use like TensorFlow. But for the NVIDIA wrappers, I'm pretty new to this package. I found it's like very helpful because it moves like data manipulation and also training your model fully on GPU. I feel like if you have like a very large data set, you're just gonna reduce a lot of training time, and also if you do like lots of like data manipulation, it's just gonna save you a lot of time. Thank you.
Thanks.
Right. Any other questions? All right. Thanks, Jeremiah.
All right, thank you.